Now that we've discussed the general trend in atomic radii, we can see what happens when an atom will form either a cation or an anion and analyze the ionic radii. So for cations, we have a particular element and it is going to lose an electron and become a positive charge. So whatever the charge of that cation is going to be equal to the number of electrons it will lose. For example, if we have sodium metal becoming sodium plus, we can look at the relative numbers of protons and electrons to help describe what's going to happen to the ionic radii. So with sodium we have 11 protons and 11 electrons. So if we generically represent the atom, there's going to be 11 protons in the nucleus and there's going to be 11 electrons that surround the nucleus. When sodium becomes a cation, it's going to lose one of its electrons, but it has the same number of protons. So we're going to have 11 protons and 10 electrons. So as a consequence, what happens here when we have one of these electrons removed? So if we remove one electron, what we have left is a scenario where there's 10 electrons. So this is kind of like a tug of war here, and the protons are going to pull the electrons closer to them. So if we have 10 electrons, the pull on the nucleus is going to be much stronger, and as a consequence, we can say that cations are smaller than the atoms from which they are formed. So if we're losing electrons, the protons that remain in the nucleus can pull on those electrons a little bit stronger, and the ionic radii is going to be smaller for a cation as opposed to an atom. We can look at a similar trend for anions. We can represent the anions as gaining electrons. So however many electrons they gain, they're going to have that particular charge. An example we can look at is fluorine. Fluorine can become an F- anion. If we look at fluorine, there are 9 protons and 9 electrons. So if we put these 9 protons in a nucleus and we put our electrons surrounding that nucleus, we're going to have 9 electrons surrounding it. But when we go from fluorine to fluoride, we remain with 9 protons and we have an extra electron. When we add that electron, we now have 10 electrons surrounding the nucleus and there are 9 protons. So this tug of war that we previously looked at for the cation is going to be a little bit different. We're adding an electron, so those 9 protons can't pull as strong as they do when we have 9 electrons versus 10 electrons. So the general trend we can say here is that anions are larger than the atoms from which they are formed. So we can now look at something called an isoelectronic series, which we'll talk about in the next video, which is going to allow us to arrange cations, anions, and atoms in order of increasing ionic radii.